Okay, so the first example we'll do is take a couple out of the book here. We'll try 18x to the 11th over 3x to the 4th. Okay, so some of these are only going to have a couple steps, but some of them are going to get a little more complicated, and they're going to be building quite a bit more to them. Okay, so here I have some exponents on variables. I also have some constants in there, some coefficients I should say. And the coefficients are going to simplify like you would normally simplify in fractions. So like 18 over 3 is equal to 6. So I'm going to leave that in there, a 6. And I'm going to leave it on top because that's where it would be, the bigger numbers on the top, so that's where that factor would end up. X to the 11th over x to the 4th, well, 11 minus 4, so we subtract those because the quotient rule tells us to, right? And so I end up with x to the 7th, and of course that's positive, so I'm going to leave it on the top. On the bottom, well, the bottom really ends up being 1 because everything is gone from the bottom, right? The 3 divided into the 18, the x to the 4th canceled out with the x to the 11th. And so 6x to the 7th is the answer. I don't need, if there's a 1 on the bottom, I don't really ever bother writing that. And so here, 6x to the 7th would be the simplified form. Okay, so we're just trying to simplify these and write as few factors as possible, but still doing things mathematically valid. So we're kind of following our rules over there. Okay. The next one, let's do one that involves maybe some trickier values. So let's try, maybe I'll make a couple up. So let's do 3x to the 8th times y to the negative 2 multiplied by 7x to the 3rd, y to the 1. I'll just say y. If there's a 1 in the power, we don't ever usually write that. Okay, so this one is a little bit different because I don't have any fractions. Again, the coefficients can be multiplied just like you would normally multiply numbers, right? So 3 times 7 is 21, so we'll keep that. Remember here, this is all multiplication. So I've got multiplying in between the parentheses, and multiplication inside. So if it's all multiplication, it doesn't really matter the order. So I'm going to take the 3 and the 7, simplify those, put those together. X to the 8th and x to the 3rd, I'm going to multiply those. That would utilize the product rule because they have the same base. And with the product rule, you add the powers. So 8 and 3 will make 11, so it's x to the 11th. And then y to the minus 2 and multiplied by y, or y to the 1. So you'd end up with, again, this is a product. Maybe I'll take this off to the side so you can kind of see this one. It's y to the minus 2 times y, and I'll think of this as a y to the 1, okay? So if you had negative 2 and 1 as your two powers, when you add them, negative 2 plus 1 is negative 1. Okay, so this is really y to the minus 1. All right, well, y to the minus 1, a negative power could be written with a positive power on the bottom. When we simplify these expressions with exponents, we always want to end up with positive powers in the end. They're just a little bit easier to understand and work with. Okay, so the negative 1 I don't really like. It's not quite in its simplest form. We're going to move that to the bottom with a positive power based upon this negative exponent rule. So final answer will be 21 x to the 11th over y now to the 1, or positive 1, because when I move the negative 1 down as an exponent, it becomes positive. Okay. again, I'm not gonna write the 1 in there, it's unnecessary. Okay, so that would be our final answer on that one. Okay.